Let's see the part 2 of electromagnetic induction. Electromagnetic induction. Let's see the question number 6. A light bulb and indicator coils are connected to AC source key as shown in the figure. So this is the inductor connected to it and a light bulb is there. Right, so it is connected to this AC having switch also. The key is closed and after some time iron rod is inserted between the interior of the inductor. Right, after switching on this switch, iron rod is inserted between this inductor. Right, so the glow of light. So it is asking about what will be the effect on this bulb. So it is asking 2020. Let's see, due to insertion of iron rod, induction of coil increases, right? So if any material is inserted between the inductor, the value changes, thus increasing the impedance of the circuit, right? Due to insertion of iron rod, inductance of coil increases, thus increasing the impedance Z of circuit, right? Thus decreases the current, thus decreases current. Hence brightness decreases. Hence brightness decreases. Right? What? So what does it means? As we know, current is equal to V by R. So it is divided I equal to V by Z, right? So as Z is increases, current decreases because they are inversely proportional. Current and impedance are inversely proportional. If Z increases, current decreases. And if you want to increase the current, you should decrease the value of Z, right? They are inversely proportional, right? So you can simply write this formula also. It is asked in 2020. Now let's see the question number 7. The wave nature of electrons was experimentally verified by. So it is talking about wave nature of electron. Wave nature of electrons was experimentally verified by. So you have to tell the scientist name, that is Davison and German. Davison and German. It is asked in 2020. Now let's see the question number 8. For the circuit given below, Kirchhoff's loop rule for the loop is BCDEB is given by the equation. So this is the equation given to it. So it is your E1. This is A. This is current I1 flowing through it, point at B. This is R2. Current is also I2. This is E2. This point is C. This point is E. This is E3. Right. So for the loop, it is given B, C, D, E, B. B, C, D, E, B. So this, about this loop, you have to tell the Kirchhoff's loop. So how can we write? By applying Kirchhoff's law. Suppose I am taking in this direction, so it will be plus, minus, plus, minus. This is minus, this is plus, right? This is plus, minus. So apply the now Kirchhoff's voltage law, applying KVL, Kirchhoff's voltage law. So it will be minus of I2 R2 plus E2. So this will be E2, and next is minus, right? Minus E3. So it will be minus of E3 plus. So it will be plus I3. It is I3 flowing through it. So its direction is given in opposite way, right? So this will be the plus I3 because direction is opposite. So it will be minus of minus that one. So it will become plus. So it is I3, value is R1. This is R1, right? So it will be R1 is equal to 0. So you can just arrange it. So take the minus common. So it will become I2 R2 minus of E2 plus E3 minus I3 R1 is equal to 0. Right. So this will be the Kirchhoff's voltage law. Please write it down. Now see the next question, number 9. A wheel with 20 metallic spokes with each 1 meter long, right? So there is a wheel, there is a center through which 20 spokes are connected, right? Like 1, 2, 3, 4, 5. And each having length is 1 meter long, right? And rotating with a speed of 120 RPM. RPM in a plane perpendicular to magnetic field. So magnetic field value is given, that is 0.4 of G. The induced EMF between the axle and rim of the wheel be. It is asked in 2020. Ninth question. See, induced EMF between axle and rim of the wheel be given as. So E is nothing but it is equal to 1 upon 2 B omega R square. Next one is second, or you can just calculate this value also. So it is 1 upon 2. B value we know, that is 0.4 of G, right? And omega we know, that is 120 RPM is given. So you have to convert into, that will be 2 pi upon 60 into R value we given, that is 1. Right. Now calculate. So it will be 1 upon 2. G will be 0.4 into 10 raised to of minus 4. Right. Into 120 into 2 pi by 60 into 1 square is 1. So it is 1 square now. So it is 1. Now calculate it. You will get 2.51 10 raised to of minus 4 volt. So this is coming out to be this value. Right. So there is no use of number of spokes. So because it is not coming in this formula, right? So there is no use of that. So it doesn't depend on the number of spokes. Let's see the question number 10. So equivalent resistance between A and B you have to tell for the mesh in the diagram given. Right. So hold for a second. So see the diagram given to you. So please make the diagram. So it is resistor here. There one resistor is also there. And it is parallel to this point. Again, the resistance. Right. So this is your 6 ohm, 4 ohm, 8 ohm. This is your A, this is your B. This is your 4, this is your 4. Right. So how will you calculate? These are in series and with this parallel. This is 8 value given. So series we will add. So you will get 4 plus 8 is 12 and it is parallel to the 6. Right. Again, it is connected like this. Right. So this is in parallel now. So how will you add? 1 upon R is equal to 1 upon 12 plus 1 upon 6. So LCM is 12. So it is 1 plus 2. It is coming out 3 by 12. So it is 1 upon 4 is equal to 1 upon R. So R equal to 4. So this value is coming out to be 4, right? So connect here. So this is 4, this is 4, this is 8. Now add all this. So you will get 4 plus 4 plus 8. So 8 plus 8 is how much? It is 16. Right. So it is asked in 2020. Very simple question. So let's see the next question number 11. Let's see the question number 11. A metallic rod of mass per unit length, that is 0.5 kg per meter given. Rod, iron rod is there. So it is 0.5 kg per meter, is lying horizontally on a smooth inclined plane with an angle of 30 degree, right? So there is a smooth plane. Rod is inclined with 30 degree, right? The rod is not allowed to slide down by flowing a current through it with a magnetic field induction. Magnetic field is given, that is 0.5 of T, Tesla. Is acting out in vertically direction. So it is vertically in direction. So current flowing in the rod to keep the stationary. So you have to find the current through it. So how will you calculate? So as we know the formula, right? So that will be the given. So magnetic field. So it will be B equal to mg, right? Sine of 30 degree, right? Angle is 30 degree now. So it will be equal to also current upon magnetic field cos of 30. So this should be equal to balance it. So put the value I we have to find, right? So I will be equal to m dash g sine of 30 degree divided by b, right? 30 and this cos 30 will be coming in this denominator. So it has become m dash g sine theta, right? B will be here. I have to find I, right? So I is here. So I will take B in this numerator and right. So put the value B is how much? B is 0.25. M dash we know that is this is your M dash mass per length. So it is 0.5. G is 10. Sine 30 is 1 upon 2. Cos 30 is root 3 by 2. So this and this will get cancelled. So it is 0.25 into 0.5 into 10. So it is coming out to be 11.32 ampere. So this is the current value. Now see the question number 12. A long solenoid has 1000 tons. So N is given, that is 1000 tons, right? When a current of 4 ampere. So current is flowing through, that is equal to 4 ampere So magnetic flux linked with the each turn of the given. So flux value is given, that is 4 into 10 raised to of minus 3 wave. Right, self-inductance of the solenoid you have to calculate. So it is given by self-inductance. Self-inductance. It is L equal to N phi upon I. N is 1000. Flux is 4 into 10 raised to of minus 3 divided by 4. So this 4 and 4 will get cancelled. 10 raised to 3 will get cancelled. So it is coming out to be L as 1 Henry. So self-inductance value is equal to 1 Henry. So it is asked in AIPMP. Now see the next question based on alternating current. Alternating current. So see the first question. It is asked in 2021. An inductor of length L. Inductor is L, capacitor of capacitance C, and resistor is R are connected in series to the AC voltage V as shown in the figure. Potential difference between LCR is given. So voltage across inductor is 40 volt. Through capacitor it is 10 volt, and through resistor it is 40 volt. The magnitude of the current flowing through LCR circuit is given. So current flowing through these three circuit is 10 root 2 ampere. The impedance of the circuit. So your diagram is given like this. Right. So it is connected to AC voltage. This is your inductor. This is your capacitor. This is your resistor. So voltage across each is given. So it is represented as VL. This is represented as VC. This is represented as VR. Right. It is asked in 2021. So let's see the explanation now. So as we know, VRMS, root mean square velocity, or voltage. So it is calculated as voltage square of VR square in plus VL minus VC whole square. So it will give the VRMS. Now put the value. VR value is given, that is 40. So it will be 40 square plus VL is 40 minus of 10. So it will be equal to 40 square plus 30 square. So it is coming out to be how much? 40 square is 1600 plus 30 square is 900. Right. So please add these two. So you will get 2500. So coming out to be 50 volt. So your VRMS value is 50 volt. Right. As we know, IRMS value is nothing. It is I naught by root 2. I naught value we know, that is 10 root 2 by root 2. So this will get cancelled. So IRMS coming out to be 10. Right. So let's see the next part. As we know, VRMS is equal to IRMS into Z. So Z is coming out to be VRMS divided by RMS. VRMS value we have calculated, that is 50. I is 10. So your Z will be 5 ohm. So the required impedance is 5 ohm. So please remember this quantity and value also. Let's see the question number second. Magnetic potential energy stored in inductor is given. Magnetic potential energy is given as 25 millijoule. right? When the current in the inductor is given. So current is 60 milliampere. The inductor of this inductance. So it is asked in 2018. So magnetic potential is given. So 25 millijoules. So convert into standard value. So it will be minus of 3 joule. So magnetic and potential energy is also represented as U. So current flowing through is given, that is 60, right? So it will be 60 into 10 raised to of minus 3 ampere, right? As we know, the magnetic potential energy stored formula is U is equal to 1 upon 2 L I square. So U value we know, that is 25 into 10 raised to of minus 3 joule is equal to 1 upon 2. L value we know, that is we have to find, right? So I value we know, that is 60 into 10 raised to of minus 3. So this will be the whole square. So, right, so it is 25 into 10 raised to of minus 3 joule is equal to 1 upon 2 into L. 60 square, how much? It is 3600 into 10 raised to minus 3 square. So it will be 10 raised to of minus 6, right? So this is cancelled with this 10 raised to of minus 3. Next is, so it will cancel this by, this can be written as 36 into 100. So this 100 is cancelled by 4 by 25, right? Now this cancel this by 2 times. So your L will be coming out to be how much? It is 1 upon 2 into 10 raised to of minus 3, right? So you will get the value how much? That is 13.89 Henry. So this will be the value for L. And here 36 is also there, right? So right here 36 into 2. So this value after the calculation you will get it. Right. So you have to just remember this formula mean how magnetic and potential energy is stored in the inductor. So it is given by U equal to 1 upon 2 Li square. Now see the question number 3rd. An inductor 20 millihenry. So inductor value is 20 millihenry. Capacitor C is 100 microfarad. Resistor is 50 ohm. Are connected in series with the EMF volt. So V is given as 10 sine of 314 of T. The power lost you have to tell. So let's see the next explanation. So how will you find the impedance first? You have to, Z is equal to, it is equal to R square plus, it is XL minus of XC whole square, right? So put the value of XL. It can be written in the form of XL also. Omega L. Omega is angular frequency L minus 1 upon omega C whole square. Right. So calculate the value individually, omega L. So it is equal to XL. So omega value we know, that is from this standard value. So this is coming out to be V equal to V naught sine of omega T. So by comparing these two equations, you get the omega, right? So what will be the omega? This will be the omega. So omega is 314. So put here in this formula, so you will get 314 into L value is 20 millihenry. So it is coming out to be 314 into 20 into 10 raised to minus 3 Henry. So exact value is 6.280 Henry XL. In the similar manner, calculate XC. So XC is nothing but it is 1 upon omega C. So 1 upon omega is nothing but It is 314 into C is nothing. It is equal to 100 microfarad. Coming out to be 314 into 100 micro means 10 raised to the minus 6. So it is coming out to be 31.84 is equal to XC. So now put all this value here in this impedance formula. So Z is equal to nothing but R value, that is 50 square. Omega we have calculated omega L, right? So this is your XL also. So put in the formula, that is equal to omega L. So its value is 6.280 minus 1 upon omega C, that is 31.84. So square that, you will get the quantities as 56.15 ohm. Impedance is nothing but it is resistance only, right? Resultant resistance. So next will be the IRMS. It is VRMS divided by Z. So it will be Vm upon root 2 into Z. Now put the value. This is V naught, we know that is 10, right? So put here 10 upon root 2 into 2. So IRMS is coming out to Z value. This is Z impedance. So I will show it different than this one. So Z is how much? It is 56.15. 56.15. Right. So after calculation, you will get IRMS as 0.1259 ampere. Right. So hence power lost in the circuit. Power is nothing but it is I square into R. So it is 0.159 after the squaring, like 0.125 whole square into R is 50. So into 50. So it will be 0.79 watt. This is the power value.